In this video, we are going to focus on revision exercise 6.1, functions and graphs. You will find this on page 293 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Functions and graphs. Complete the table of the value for this. Now, I'm not going to revise it in the textbook, but in the textbook I did so many examples in the blocks. So if you go and if you struggle a little bit, just go through the blocks from page 236 to page 272 in the textbook. And even as I said, even if you just focus on the ones in the blocks, it's really going to prepare you for a question like this. Okay, but I'm going to start with it. So complete the table of values. Now stop there. This is a what equation? This is a quadratic equation. And I'm going to now, I want to go to the summary. And please work at that summary. It's really going to help you. Now, if you look at the summary, let's just go back. Just want to see. I know there was one with the printing error. Okay, it seems to me I just took it away. So the constant function is just y is equal to 4. Are you with me? So just for the interesting, I think I took it away. But if you want a line, I always say if it's only y equals, it only cuts the y-axis and it cuts at 4. If it's x equal, then it will only cut the x-axis. And say, for example, that was negative 3, then that equation will be x is equal to negative 3. Okay, that is that line. Now, this is a straight line. If it's going through the origin, I even want to make it bigger. Okay, if it's going through the origin, then the value, actually this is the name of the textbooks, y equals mx plus c. That means this straight line to success. So if you do all this calculations in this book, all the different exercises, that will be your straight line to success. Okay, so if the value of c is 0, it will go through the origin. And then if the value is not 0, say for example it's like this, then this one can be y is equal to let's say x plus 5. Okay, or something like this. So then it's cutting there at 5. I'm not, but then it will not go through 0. If the gradient, and can I just show you here? I want to even make it still bigger. If it's positive, no, not so big. Let's just go back. If it's positive, then it will go up. Then it's a positive there. Do you see? There's a positive. And if it's negative, it will come down. Okay, so take note. But this is a straight line. It's only to the power of 1 to the power of 1 to the power of 1 to the power, and it's coming from this formula. A quadratic will be x to the power of 2, and it's a parabol. But it can be, this is positive. And remember, I like to say, oh, you are a positive person. Or if it's negative, look, this person is angry. So the value will be negative in front of the x squared. Okay, now it can also move up. So there can be a 2x plus 3. Then it will move up or it will move to that side. But quadratic is always the parabola. And then the next one, if it's cubic, if it's x to the power of 3. But can I just show you, if it was y, now I want to take another color. If it was y equals negative x to the power of 3, then it would first go like this. Then it will first be a negative gradient. So their gradient, if it's positive, do you see? Is positive, then the gradient starts positive and then it goes up. Okay, and again there can be a 2x squared plus 3x plus 2, and we go deeper into this in AS level. A reciprocal is where the x is at the bottom. Do you see there? If the x is not like there on the top, is at the bottom, but it's still to the power of 1. Then it's either like this, if it's positive, and if it was, say, y equals negative 6 over x, then it would have been something like this. And then this one, if it's, and this is usually not something that we get, but this is the exponent. So now it's a 2, but it's a, and then it's giving me this kind of sketch. So it's very good if you know the summary, and you will see in the exercise, I'm going to reflect back to this. Okay. Now, why did I show it to you? Sorry, I just have to go back. Okay, I showed it to you to show it's an x squared and it's negative. You can actually, if you want, it's not necessary, you can rewrite it like this. And then you see, oh, it's going to be a parabole like this. It's always good to have a picture in your mind. Okay, but they start by saying find the open spaces or find the value of A and B. And how do I do that? I'm just going to do substitution. So leave the formula as it is, and I prefer if it's quadratic that you do it not just on a calculator, otherwise you make sometimes unnecessary mistakes. So I'm going to substitute -1 and I'm going to substitute it in the place of x. So it's going to be 5 plus -1 minus -1 square, and that's going to be 5 minus 1. This becomes a positive. You first have to bring this -1, and my value is going to be 5 minus 2, and it's going to be 3. And therefore, I say, therefore, what is that? A is equal to 3. Okay, let's do the next one. Number B. Y is equal to 5 plus x minus x squared. And now again I substitute, and what do I substitute now? 1. I do it in brackets, especially if it's negative, it's very important. So it's 5 plus 1 minus 1, and that will just be 5. So therefore the value of P will be equal to 5. Okay, and that's easy marks to get. Just do substitution. Okay, now they were very nice. They gave me the graph paper and they already marked it. But if they did not do it, it's not so difficult. You just look at the values here. So in this case, they say on a sheet of graph, we're using a scale of 2 centimeters to represent 1 unit. So every 2 centimeter is 1. So it's 1, 2, 3, -1, -2, So this scale must be the same. But then it can be a different scale to this one. And then 1 unit on the x, okay, and 1 centimeter to represent 1 unit on the y. So every centimeter is going to be 1, 2, 3, and the same to the side. So the scale is correct. And now you must plot the points. Now from -3 to 3, I prefer that you plot it with a cross. Because if you make a dot, you make it sometimes too big, and then it's inaccurate. So I take it's -3, there's -3, and -7. I'm even going to make it, no, can I make it? No. I just have to, and -7. I just want to see, maybe I can try a little bit bigger. Yes, because it's also looking, I will just check because now the graph looks better. I don't see the table, but the table I have, you have it also in front of you. So let's just make that mark again. I prefer to do it very accurate. Okay, and then the next one, -2 and -1, and then that one will be there. And then the next one, -1 and 3. And then the next one, 0 and 5. And then the next one, 1 and 5. Oh, I like that they gave it like this. I will tell you now why. 1 and 5. Sometimes just with my pen. Sorry. I'm trying, but my pen is not doing what I tell him to do. Okay. And then 2 and 3. 2 and 3. There's 2 and 3. And then 3 and -1. Okay, excellent. Oh, I'm going to struggle with my pen again. Can I just tell you, if you come there, you may not use a ruler. You must do it freehand. But please don't go like this. Because it's a parable, it's almost like having a little kuppel, whatever you call it. So you will just go a little bit higher and then, but don't go flat there. Okay, so I'm going to try to draw it to the best of my ability. I always do, you can move your paper, I cannot do that, but I like to focus with my one eye on this one, with my one eye, then sometimes it's a bit better. Oh, I think that's not so bad. Okay, and if I pick up, I usually pick up at the point so that it's not noticed. What I want you to do it in one action. Okay, that's my best I can do on my technology. So let's just go a bit smaller again. Okay, there's my graph. And please, you must plot all the points, otherwise you will not get your free marks. And then you must do a curve free-handed. And now they start with the questions. And if you're going to work through my blocks, you're going to find so many nice questions. So use your graph to solve the equation. I want you first to focus here. I want you to see that this is exactly this. Very important. But then, in the place of y, they was just putting a 2. So they are actually saying that y, I must rather take another color, green, y is equal to 2. And I showed you. So you must draw that line in, y equals 2. It's a line that cuts the y-axis at 2. Okay, the y-axis at 2. So I take my ruler. Sorry, I have to go bigger again, otherwise I will struggle with the graph. And I draw the line, y is equal to 2. Okay, there it is. And I can even make it now. And I said, use to solve. Now, just for the interesting, you can use algebra, but they don't want. They want you to use the graph. But if it was asking algebra, I will take the 2 over and then I will factorize or use the quadratic formula. But now they want me to use the graph. And I use the graph. So there where the blue and the green intersect, there, I'm taking my ruler again and I go down. And I read down. And I go down. And I read down. And according to me, and I'm just going to go make it smaller, so it looks like negative 1.3, okay, and this looks like 2.3. Okay, so I can go smaller now. It's just with my graph. Okay, so here it is. I'm making space. I like making space. Sometimes they answer it on top of the graph paper, but now they gave you the graph and I think you're going to do a full in. I don't know, but then it's easy if they gave you. So it's going to be 1. I'd rather take another color, C. Then you are reading from the x-axis. So it's x is equal to negative 1.3 or x is equal to 2.3. So if, and I just like that you know a little bit what you are doing. Say, for example, and it's not, that you were doing it with algebra. You would have, okay, say you would have taken the x squared over, okay? Say you put the 0 there, the x squared over, and then the minus x, and then the 2, and it's negative 3. And you solve this with the formula. Can you remember that formula? You have to memorize it. Plus minus b squared minus 4ac over 2a. And you substitute the 1 and you substitute in the place of b negative 1c. Then you would get the exact values. But they don't want that values. I just show you in algebra, I would have done it like that. But now they want to see where the two graphs intersect, and they want to see, and they check on your graph that your values correspond to the values you are writing down. But they give a range, so try to be as accurate as possible. I see in my textbook, I give the range -1.4 to -1.2 and 2.2 to 2.4. So I give a little bit of space, but you must be in that space. Okay, I'm going on. Complete the table of the values for the equation. Oh, they were so nice. They're not always going to be so nice. This is a straight line. Sometimes they don't give you the table. They just say, draw the equation y equals 2x minus 1. Then you must create your own table. And then if you create your own table, just take the value. Take, this is x, y, take -3, take a middle one, take the end one. And that's exactly, so they were very nice. They helped you and they already created the table for you. But just please remember, if they give you a straight line and they want you to draw it on this curve and they don't give you a table, create your own table. Okay, or yes, no, I think rather to create your own table. I come to linear programming and then I tell you the other method. Okay, so for now, I'm doing exactly the same again. And this is di, and I'm just writing my equation down. So y is equal to 2x minus 1, and y is equal to 2, -3 minus 1, and that's -6, -1, and that's -7. Okay, so this is -7. And if you are doing a filling in, go and fill it in there. Then I do it exactly again. I start, you can do it this one on the calculator, but I'm sometimes so afraid you might make unnecessary mistakes. Okay, and then I fill it in and it's -1. And then the last one, I say y is equal to 2x minus 1. And in the place of x, I put a 3. So it's 6 minus 1 and it's 5. And I just go and I fill in a 5. Oh, and again I get my 2 marks. I'm just going to, don't like so many things written here. And I also don't want so many things here. Okay. Now I'm going to start. Now on the grid, draw the straight line. Now this is very, very, very important. They want you just to do it from -3 to 3. From this point to this. If you make it longer, they will subtract a mark. If you make it shorter, they will subtract a mark because they gave you that range. So I will plot that points, -3. I'm going to make it again bigger. I see nice. Okay, so it's going to be -3 and -7. Oh, it's exactly the same point. Do you see there? And then it's 0 and it's -1. And then it's 3 and 5. 3 and 5. And then I take my ruler and, yes, I think, what do I want to do it with, red or blue? I think I have to do red. From this point, with your ruler, and it's again to 3 and 5. There. Okay. It's always good if you name your lines. So this line it's always just giving it a name. And the name must be the equation, the quadratic equation. And this one's name is going to be y is equal to, and what was that equation? It was 2x minus 1. Can you see the gradient is positive, and that's why the line go upwards. If it was negative, it would have gone downwards. Okay, then I make smaller. Okay, and now write down the gradient of this line. You don't have to, you can say, okay, the difference in y over, because gradient, but it's not, don't do it like that. I'll show you just, it's working. But I'm first going to do it. You just check. Remember what I said is the book's names. Y equals mx plus c. And that value in front of x is the gradient. So if I'm doing it, I'm just going to say, okay, my question was d, I, and the value of m, what was the value of m? It was 2. Okay, I just I'm reading it. But say they didn't give you the equation. Because I'm doing a little bit of revision, you would have taken your 2 points. And what was your 2 points? I could have taken this point, and this point was then 3 and 5. And I could have taken this point, any 2 points on the line. And this point was -3 and -7. And this is going to be, okay, x1, this is point 1, y1, x2, y2. And then to find the gradient, and we're going to do it in coordinate geometry, it's always the difference in y over the difference in x. In the coordinate point, it's first x, but in the gradient, the y's will be on top, so don't get confused. And then I'm going to say I'm just doing substitution, -7 minus 5, just showing you the algebraic way, and this, because we're going to do it in coordinate, and then it's -12 over, what will this be, -6. And then, a negative divided by a negative is positive, and 2, and it's exactly the same as you got there. The value of m will be 2. And then write down the coordinates of the points where the line intersects the graph. Okay, so let's go, make it big, make it nice big. And where does it intersect? Where does it cut? I see 2 points. I see here. Do you see? And I have to take another color. It's here and it's there. And if you write it down, I'm just going to make it smaller again. And that will be number E. Okay. And that will be -3 and -7. And what is the other point? It will be there, it will be 2. Do you see 2 and 3? It's just where the 2 lines intersect. This is a very, very basic one. I will almost call it in the old syllabus a core one. But if you look in the textbooks and if you look at that pages from page 236 to 272, you will find more extended ones. But as I said, just do the ones in the blocks because that's running through all the type of methods they can ask. Okay. This is a very easy, it's coming from physical science, and I think people who have physical science, this will be easy. This is practical graphs. And again, in the textbook, if you're going to check in the textbook, you can just quickly refresh your memory by going, and I'm writing here, it's on page 273 to 284. There you will run through all the practical graphs, but it's also coming a long way. It's really not so difficult. Okay, it's a bit more difficult, this one, because it's speed and time. If it was distance and time, it's not so difficult. But I want you, I always like, when I see speed and time, I think always of my triangle, and I like my D is TV. Okay, so D is TV. So if I want to find distance, it's speed multiplied time. If I want to find speed, it's distance divided by time. And if I want to find time, it's distance divided by speed. And that's the reason, and I just mentioned it now before, because distance is speed multiplied time. So say you want to find that distance, just the yellow. This is a rectangle, so it's length times breadth, and the length is speed multiplied time. And that is the reason, if you want to find distance, it will just be the area under the graph, and it's coming from that speed multiply. There is just a triangle, so it's half base times height, length times breadth, but that is coming from there, and then you will be able to find the distance. So keep it in mind. I think we're going to work with this. Okay, let's start with number 8. Calculate the total distance. Oh, it's so nice. Total distance of the journey. Give your answer in kilometers. Okay, so this is time, and this is nice. This time, look here. This must be speed per minute, and then this must be the same. And I don't think they're going to make this hours and this minutes. Not on this level. Okay, so I think they will be nice. So if I just asked you to do, so don't forget, and I'm just writing total distance, and I'm writing it now nice. So I say total distance. And I say it's going to be the area under the graph. And now we just think geometry. And if you think geometry, this is going to be a triangle. Do you get that triangle? I think what I'm going to do is I'm going to make it different colors. So let's make my triangle green, and I make my rectangle blue, and I make my this triangle red. So it's just going to be, now I must just redo this. So now let's start with green. It's going to be triangle, green triangle, plus, and then my blue rectangle, and then plus, and my red triangle. Okay, and you have to know that formulas. Please memorize it. I will show you when we come to geometry, but that's also part of the things that you have to memorize. Okay, so what is the area of a triangle? It's just going to be half base times height. Okay, so this will also be half base times height. What is the area of a rectangle? It's just going to be length times breadth. And now I'm just going to work in white, otherwise it's too many colors. Okay, so what is the base? It's 4, can you see? What is the height? It's 3. What is the length? Just be careful. It's 50 minus 4. Do you see that? So that is going to be 46. Do you see that? And what is the breadth? That's going to be 3. Okay. What is going to be your base? 60 minus, it's 10. And what is your height? 3. And then I'm going to, if I multiply this, I get 6. If I multiply this, I get 138. And if I multiply, a pen again, 138. If I multiply this, I get 15. And that is going to be 159 kilometers. Okay. Okay. That's the total distance. Easy. And then, okay, now this is a bit a rate sum. Very nice. Let's do that rate. It's coming from chapter 1. Okay, so number B, the first, convert, and I do it always like this, 3 kilometers per minute. And they want it in meters per second. Now, I always do it with my tables. Then I don't make mistakes. So with my tables, it's just going to be now, okay, kilometers, meters, centimeters, millimeters. I will now, and then it was hours. No, okay, let's just first do that one. So there is 1 0, there is 2 zeros, there is 3 zeros. If I go to this side, I times, and if I go back, I divide. So please know this. And then time is also easy. It's just, you know it, hours. Oh, I want to make it yellow. This is hours, minutes, seconds. And this is 60. And again, if I go to this side, I multiply, and if I go back, I divide. So first, from kilometers, is it to meters? No, let's just see. From kilometers to meters. So I'm writing in, I multiply by 1,000. And from minutes, this was minutes to seconds. But be careful, minutes, I multiply by 60. And then I'm basically just taking my calculator and I press. I say 3 times 1,000, divide by that 60. And what do I get? I just want to see if I made a mistake. Okay. I just want to see from minutes to seconds. Yeah, this is correct. I just think I didn't multiply it correctly. So it was 3,000 divided by 60. Yeah, that is correct. And that will give me 50 meters per second. So just write your tables down for the top, the bottom, write what you must do according to the tables, and then just press it on your calculator. That's easy stuff. And then calculate the acceleration of the train during the first 4 minutes. Now, that is basically that green triangle. Then don't forget, what is acceleration? Acceleration is, it's going to be speed divided by time. It's almost like the gradient. But I just want to see with my units. This is meters per second square. Okay, do you see? So if I'm going to, I must take this to seconds. Okay, so if I'm going to look at this 4 minutes, I'm first going to take the 4 minutes. And I'm going to be, it's due to this. That this was in minutes and this is in seconds. So I take my 4 minutes and I'm taking it to seconds. So to take it from minutes, I just multiply with 60 and then I get 240 seconds. Okay, and now, so my 2 points is, let's just see, what is it, 0 and 0. And this is going to be 240 and 50. Okay, are you with me? Let me just see quickly. Basically what they did is usually that they will let you do I to help you. Yeah, these two will help each other. Now, you were converting there 3 kilometers per minute. You were converting to meters per second. So this 3 would have been 50. They were helping you. Meters per second. Are you with me? And this 4 minutes will be 240 seconds. So it's just, I'm busy just converting it. And now I just want to find acceleration. So acceleration, don't forget, can I just write it here? Acceleration is speed divided time. It's the gradient. Now, what is the speed? If I'm going to look, because it's just from 0, so it's just going to be 50. And what is the time going to be? 240. Because this one is in meters per second, and this is in seconds, so the seconds will cancel out, and I will just get 0.208 meters. Now, it will not cancel out. Can I show you? Because it's going to be, and I divide by, okay, I divide by seconds. Can I, I'm showing maybe too much. So it's going to be meters over second. I multiply the reciprocal. Do you see? So it's going to be meters over second square. And that's why it's meters per second square. It's not cancelling out. If it was 1 over s, it would have cancelled out. Okay, and that's the final. So they helped you. They let you do I to help you in this one. This one was a bit more challenging. Okay, let's go for the finals. Functions. Now, before I do functions, I just want quickly to refresh your memory. I cannot do functions without basically just quickly refreshing your memory. And as I said, I'm going to do it. It's going to be in your textbook. You can go on page 226. 226. It's in the beginning. Okay, I think it's here. And as I said, it's really not difficult. Okay, so I'm more going to focus just on the evaluating a function. It's actually just a graph, and you will go deeper in AS level into it, and it's cut, and it only cuts once. Okay, so if you have any graph, maybe, okay, so for example, like a straight line, that's definitely not a straight line. Let's rather make it a straight line. And then if you cut, it only cuts one time if you draw a vertical line. But say, for example, you're having a circle and you draw that vertical line, it will cut 2 times, then it's not a function. Okay, but I want to focus on evaluating. Now, I like to say there's 3 things that you must be able to do. And the 3 things is, okay. The one is they will put the value there. The other one is they will put the 2 there. And the other one, they will ask you to find the inverse. That's the 3. Now, if they put the value there, you substitute in the place of x. Now, don't forget, and please, a function it was an equation. Let's make it a straight line. Now, another way to write y is to say it's the function of x. So basically, they are just in the place of y, they just write fx. Okay, so if I say fx equals 2, it means y is equal to 2, then I replace in the place of y. But if I say, in this case, in the first one, I replaced in x, and in the second one, I replace in y. And then I will come to the inverse. So if I'm just running very briefly through this. So, because I will look, it's really not difficult. So if they ask you, so I will just take my equation, and in the place of x, I will substitute 3. That's all. Then I will substitute -2, then 0. That's the first one. The next one. If they, and I'm as I said, I'm not going to go too deep. You can go through all the blocks, which is always nice for revision. But now they give you fx. Fx is in the place of y. So now I will take out this whole side, fx, and I will put a 3. Not in the place of x, in the place of fx. Okay, and then I will use algebra to solve this. It's a linear equation. So then I will say 2x, I take over, I divide, and I get. So again, I substitute in the place of fx, in the place of y. So make sure that you don't get confused between 1 and 2. I'll reflect back on that. And then, as I said, I'm running very briefly through this. I want to just tell you inverse functions. Now, inverse functions is actually very nice. There's 3 steps. And just remember it like this. And I'm just even going to redo this one. So if I have, this is now, they will do it like this. That negative means, oh, I must find the inverse. Now, if the equation was like this, inverse is just like this. In the place of fx, I replace, it was originally y, so I put y back. The second step is wherever I see a y, I make a x. And wherever I see a x, I make a y. Okay. And the third step, I make y the subject of the formula. So I leave it to y, and it's going to be x minus 7. And now I just divide 2, and I will get that y is equal to x minus 7 over 2. But they're going to penalize you if you don't do this. This new y must be f minus 1x. And you must, in this place of this new y, you must write f minus 1x. And it's x minus 7 over 2. That's your answer. So that's your 3 steps. Can I just run through it again? In the place of fx, you put a y. That's step 1. Step 2 is where you see a y, you make an x. Where you see an x, you make a y. And then step 3 is you make y the subject of the formula. And that's that. Okay. I must go further a little bit. I must show you quickly composite functions. Now, composite function is just two functions. Again, also not that difficult, and I'm just refreshing very fast. If you get a value, it's now two functions. They give you two, not just one. Okay, so basically, now, if they give you two, always just remember you start from the back, So you will first, in the back, you will first find f negative 2, like we did with the first one. Then you get a value. And then, so that will become a what? A 6. And then basically you're just going to get G6. So it's almost like you cover first that one and you first work out this one. And that answer you put in G. And if you do this one, you will first, from the back, in G, put negative 2. Did you see? And then that answer becomes 0. So you're actually going to find F0. Okay. And then you will find your answer. Okay. And then the last one, which I would just want to run through, and then I will just look at the examples. And these very nice examples, is that if there's not a value, if it's just two equations, then there's now not a value. Do you see what I mean? There's not a 2 or a 3 or a 4. Then it's just like this. You just take the equation, you start still from the back, you take f and you throw it in G. So whatever there is f, and I throw it in G in the place of x. There I put a bracket. It's like substitute. I substitute f in G. So there I showed you nicely. Then don't forget the square. It's now algebra. So write the two brackets out and just get it, and you just end up with an expression. And if I do this, now again you start from the back. So you go to G first, and you throw it in there. There you throw it in. Okay, and you work it out. And that is basically functions. Let's go back to the exercise. Okay, I'm going to just make space again. Okay, we're running to the end of this video, luckily. Otherwise the video is so long. Okay, but let's just do the end, the finals. Okay, so I have my functions, and there's 3 of them. So I'm not even going to rewrite it first, just want to show you. There you see one, there you see another one, and there you see another one. Okay, they have different names. So, I actually start difficult and then I go easier. Okay, but it's all right, you can do it. Okay, so I ask GF3. Can you remember what I said? Start from the back. So first go and work out F3. Now can you remember? I go to F, and I think I must keep my colors here. F was red. So I find F3. And then I say it's 1 minus 2, 3. And that's 1 minus 6, and that is going to become negative 5. And now, actually, I must find, what was G? It was blue. I must find G negative 5. So I can say G, or usually they write it then like this, as they ask. So they say G, F, 3, and then they will just in G, but I think it's better that you first write G negative 5. So in G, I will just put there a negative 5. But where's G? So it's 1 over X. So it's, remember, G, can I show you? Gx. It's 1 over X. So it's 1 over that negative 5. And that's my final answer. Okay. So just remember, first do this one, and that answer you substitute in G. And I said the second one was easy. It was like the first one I showed you. You just, in the place of H, and I want to make my color again. It's green. So in the place of H, I just put a negative 3. So I go to H, and I put negative 3 to the power 3 plus 1. And this will be negative 27 plus that 1, and that will be negative 26. So please don't leave this out in the exam. It's very basic. Just go through the blocks. Make sure you know the 3. And as I said, there's 3 types of things. They will also, first they can ask f negative 3, then f x equals negative 3, where you substitute in the y, and then they ask the inverse. And then they can come to the combinations. But it's not difficult. Okay, and now, look, this is a nice question. It's touching all of them. So look here. Okay, so number B. Okay, so number B was then H, G, X. And now, it's almost like, I'm going to show it to you. I take G, I go to G. Now, where is G? G, this one. I go to G, and I throw it in H, in the place of X. Do you see? So I just start writing, and it's to the power of 3. So it's going to be 1 over X. So make arrows for you. It's going to help you. And then it's just going to be 1 over X to the power of 3 plus 1. You can make the denominator, so you can say multiply x3, multiply x3. So it's going to be 1 plus x3 over x3. But I think that will also work. But this is maybe the more simplified answer. Okay, so that was just throwing one into the other one, and start with the back. Go make a circle around that back and throw it into the front one. And now number C. Okay, so if I'm looking at number C, it's H minus 1x, the inverse. Now, first start with, what is hx? There's that 3 steps I told you. What is the first? Make it a y. That's step 1. Step 2, where you see a y, you make an x. Where you see an x, you make a y. Step 2. Step 3, make y the subject of the formula. Keep it there. Bring that one over. And now, take the cube root. And now, just going to make this the new. So, don't make it f. The name is not f, the name is h. So, h minus 1x. And it's going to be x minus 1, 3. If it's cube root, you just write the sign. But if it's square root, don't forget your plus minus. But it was not a square root. And that was your final answer. Okay. And then the last one. The last one. Write down which of these sketches show the graph of each f, g, and h. And now, remember that summary I showed you. So, if you look, you will see, okay, this red one is a straight line. So, it can either be this one or this one. The rest is not straight lines. Now, I just look at the gradient. The gradient is the value in front of x. It's negative. So, negative is down. Let's see if this one. Oh, both is negative. Wow, it's interesting. Now I must see, but where does it cut the y-axis? It cuts the y-axis at positive 1, and there it cuts at negative. So it's cutting, that should have been positive 1. Can you see there? Oh, so this was a bit not, so both was negative, but due to the y value, you will decide that that one was graph A. So let's say, it's number D. So y equals fx was graph A. Okay. Now the next one, g. Now g, this is a reciprocal function. Okay, it's a hyperbole. So you will see, where is the hyperbole? Oh, here is the hyperbole. And there's only one hyperbole. And it's also, let's see, it's 1 over x, it's in the positive. If it was in the negative, if there was a negative 1 over x, it would have been in this 2 quadrants. But this one is nice, so I say y equals gx, and that will be graph f. And the last one, y equals hx. This is cubic. Now, this is, there's not even. Cubic is like this, or like this. But now, there's a positive. Do you see? It starts positive, and I showed you if it's positive, it first go up, and then it's 1, and that one cuts with a negative. So, no, it will definitely be graph D. And then so it's really, make sure you know that summaries very well, because that gives you a clue. It also bring all the rules, all the formulas. So maybe tomorrow when you are writing exams, the morning before, just go through that summaries and make sure you know the basic concepts.